Hello everyone, today we are going to solve a very interesting problem, maximum frequency stack. So let's understand the problem statement first. Basically we have to design a stack like a data structure where we can push element and the pop the most frequent element which is closest to the stack top. Okay, like if we have a two element which have the same frequency, then we will remove the element which is closest to the stack top. To understand the problem in a better way, let's understand the with the example. Okay, so we will have this stack. We have a stack which is 5757. So we have a stack which have a value 5 7 5 7 4 5. Okay, so first of all we find the most frequent element, and most frequent element will be 5. Okay, and we will pop it out. So first will be 5. Now our stack will be 5 7 5 7 4, and the most frequent element will be 5 and 7, both have the same frequency. So we have to remove the element which is closest from the stack top. So it will be 7. Okay, so we will remove 7 and return 7. Now our stack will be 5 7 5 4. Only 5 have the two frequency, so we will pop 5. Okay, now our stack will be 5 7 4. In 5 7 4, all of them are the same frequency, then we will remove from the stack stop, that will be 4. So our answer will be 5 7 5 4, that is 5 7 5 4. So how we are going to solve this problem? So for this problem we are going to use two data structures. First is unordered map and second is priority queue. So we are going to use unordered map to count the frequency, of each and every element. Okay, and we are going to use the priority queue to sort the element frequency wise. Sort element frequency wise. And if two elements have the same frequency, then we have to sort according to the position, of the element. Okay, so what this is pointing is, this is our frequency of the element. Okay, this is the position of the element, and this is the element itself. Okay, so let's understand with the one example first. So we need another map which will count the frequency, and we will have a one priority queue. So first of all, 5 is pushed. As 5 is pushed, we are going to mark the frequency of 5 as 1, and we will put in a priority queue as frequency 1, position will be 0, and element is 5. Now we are going to push 7, so we will add in the frequency map. Frequency of 7 will be 1, and we will push 1, first position, and 7. Now again 5, so we will increase the frequency to 2, and we will add 2 2 5. Then 7, so we will add 2 3 7, and increase the frequency of 7 to 2. Then 4, so 4 will be the 4 frequency will be 1, so it will be at this position. 4 this position, 1 4 4. Okay, then we will have a 5, so it will be 3 5 5. Okay, and frequency will be 3. So now when we are going to pop this element, so first of all the most frequent element will be 3. The frequency of 5 is 3, so we are going to pop this and decrease the frequency of 5 to 2. Now we have a stack, this is our stack, and the frequency of 5 will be 2. Okay, now we again pop the element which is the 7 and decrease the frequency to 1, and then again decrease 5 frequency of 5 to 1, and remove 5, and then we need this. Sorry, this will be here, because it's 4, no? So now we are going to remove 4, and remove the decrease the frequency of 4 to 0. That means we are removing from this. Okay, so this will be our solution. Let's see the code to understand it. So this is our code. We are using a priority queue and pair of int which show the frequency, then position, then the element, and one order map which will use for the calculate the frequency, and one position. This will use the, we are going to use a variable position to know the position of the element at this step. So in post we are simply increase the frequency of that element in map, and then we are increase the position value and adding the val as the pair of pair. Okay. Now we are copying the top element from val and the second to second element. We have frequency, then position, then val. So second element will be this where position and val, and the second will be the element itself. Okay, and we will going to reduce the frequency and then return the that element. So this will be the code and the solution, first solution of our problem. Now let's understand the second solution. The time complexity of the first solution will be O of log n, because the maximum heap and the push and pop operation in the maximum heap is taking O of log of n, and the space complexity will be O of n. Okay, so can we have a better solution? Yes. So what we are going to use is we are going to remove the priority queue, and we are using an order map which have the int which will show the frequency, and we are using the stack. Why stack? To see which is the closest to the stack top. Okay, so let's understand the same example with this approach. So first of all, we are using one frequency map, and we will have another map which is the map of stack. Okay, and we will have another variable which is max frequency. Okay, this will the max frequency. So let's understand the first. So first we are going to post 5 to the stack. So we will have a 5 with frequency 1, and we will post the frequency 1 and having a stack 5. In the stack we have only 5. Okay, now we are going to post 7. 7 frequency will be 1, and 7 will be here. Okay, in the same stack, because the frequency of 7 is also 1. Now we are going to post 5. So increase the frequency 5, and we will have another element in the stack map 2, which is 5. So basically what we are doing is we are if an element have the frequency n, so we are going to insert n, that element n times in the map, n times in map. Okay, so let's understand here. Now 7, we will increase the frequency this, and we are going this 7. Then 4, so we put 4 here, and frequency of 4 will be 1. And finally 5, it will be 3, and we have 3. Now while pop out, what we are going to do, we have the maximum frequency as well. We are updating maximum frequency. Right now it is a 3. Okay, so what we are going to do, we find the the element which has the maximum frequency, and maximum frequency right now is 3. So we will find this and see this is the stack. Okay, and stack top is 5. So we will pop out 5 and remove it from here. Okay, now if this stack is empty, while remove this, now this stack is empty, so we will decrease the max frequency to 2. Okay, now max frequency will be 2. So now again we see 2 here, and we have this stack. Okay, and from this stack, first we will pop out the top of the stack, that is 7, and then we will see, is it the stack is empty? No, we have 5 in this stack, so we are not going to decrease this. Again we are going to see the map having the frequency 2, so this is the element, and here we have a 5, so we will remove 5. Now this stack is empty. Yes, so we will decrease the frequency by 1 and come here, and now remove the 4 top stack, and our answer will be 5, 7, 5, 4. I hope you understand this. If not, try to watch this video again. Okay, and I am sending you the code. You can see this. Okay, so we have another map which have a map of stack, and we have a another map which is calculating the frequency of each and every element. We have a variable max frequency which is 0. Okay, so first we are going to push. So how we are going to push? Before pushing, we check the max frequency is updating or not. Max frequency is updating or not, and after that we are going to push that element into the map of stack. So how we are going to pop it? We are checking the max frequency element in the map of stack and remove that element, and if that is empty, if the stack is empty, then we decrease the frequency and return that element. I hope you understand this problem. So what is the time complexity of this? So time complexity of push operation is O of 1 and time complexity of pop is O of 1. So overall time complexity of this program is O of 1 and space complexity will be O of